Good morning, boys and girls, and welcome back. Today we're going to be talking about exponential models. We're going to begin with a quick little review of our separable differential equations from yesterday, and then we'll kind of move on from there. All right, so we're given this differential equation here, and we are told to solve for y. Now, again, if you're given this and you're told to solve for y, they don't want you just to get the y by itself and 2x over y prime. That's not what we're going for here. We want to go back to the general solution. Okay, so solving for y is another way of saying find the general solution. All right, and so if we're going to do this, we need to separate variables. So I'm first going to rewrite my differential. Then again, we're going to want to try to get y's on the left-hand side and x's on the right, generally speaking. So I'm going to multiply by y and multiply by dx. And then now we're going to want to integrate both sides, with the left with respect to y and the right with respect to x. So we get y squared over 2 equals 2x squared over 2 plus c. And again, we only do the 1 plus c. And now we can simplify that to 1 half y squared equals x squared plus c. And now we're going to solve for y. So multiply both sides by 2. Y squared equals 2x squared. And again, we would still just put plus c. 2 times c is just some new constant c. And then I would square root both sides. And so we get y equals, don't forget when you root, plus or minus 2x squared plus c. And that c has got to be inside the radical. And now we have solved for y. All right, one more separation of variables review question. All right, so here's our next one. dy dx equals 4 minus y. And just thinking about it, I want to let you know that these are a very common free response question on AP exam. They're generally worth, of the 9 points, 4 to 5, sometimes even 6 of the 9 points. Okay. So as we go through this one, I'll try to explain where you will normally see your points come from on an FRQ. All right. So step one, I guess you'd get your first point by separating your variables. So in this case, I multiply both sides by dx and then divided by my 4 minus y. And so I'd get 1 point for that separation of variables. Okay. Then you would get another point for the antiderivatives of both sides, or sometimes 1 point for just the antiderivative if the antiderivative is the same. In this case, we're going to use 2 different types of antiderivatives. So I'd say in this case, we'd have an antiderivative point for each side. All right, so on the left-hand side, 1 over 4 minus y. This is technically a u sub integration. You would say u is 4 minus y. And so the antiderivative of 1 over u is ln of u. I'm not writing out my u sub, and if you are feeling comfortable enough, you do not have to either. Although if you are confused, write out your u sub. Say u equals 4 minus y, du equals negative 1 dy, and set that up. If you don't do it though, again, think about chain rule. If I were to take the derivative of this, it'd be 1 over 4 minus y times a negative 1. So I do need a negative out in front of this thing. But I think you might be getting to the point where you don't need to set up the u sub. But if you do, there's nothing wrong with that, and set it up. On the right-hand side, the antiderivative of 1 is x, and then again, don't forget plus c. Now we need to solve for y. Okay. So again, I'm going to get rid of the, well, actually, I probably should, before I do this, I want to get rid of that negative. So I'm going to divide both sides by negative 1, would give me ln of 4 minus y. X divided by negative was negative x. Again, c is just some constant. We don't know if it's positive or negative. So that, again, always stays plus c. Oops, sliding up. Okay. Now to get rid of the ln, I would exponentiate with the base of e. Remembering that all of this is now in the exponent, and we could rewrite this as e to the negative x plus e to the c times e to the c using our power rules. Okay, when you multiply bases, you add exponents, and this becomes some new c value now. So we have absolute value of 4 minus y equals c e to the negative x. All right, and now we're just going to have to work on getting rid of our absolute value. We said in the previous lesson to do this, we technically have to set up case 1, case 2. But instead of going to all that work that we did last time, we're just going to say this. And we said we could just come to the side and be like, A equals our plus or minus c value for the case 1, case 2 for absolute value. And now we can just drop all absolute values and write it like that with an A instead of the C. since c technically had to be positive up here, since e to the c is positive. And now we're going to continue to solve for y. And now I'm going to divide everything by -1. And this a, again, is positive or negative, so we can just leave it a. And so there is our equation, our general equation for this one right here. All right, so now let's talk about our exponential models and population growth. Okay, what we know about population growth is that the rate of growth of a population is directly proportional to the population itself. What we mean by that is, the bigger a population, the faster it's going to grow. The smaller population, the slower it would grow. The rate of growth is directly proportional to the population. Okay, makes sense. Now, mathematically, what that means is the rate of rate of change is the derivative, and that is directly proportional to the population itself. Remember, we talked about direct proportionality. This would be my direct proportionality equation. All right. So now we have a differential equation that we can play around with. Let's do that. All right, so we changed our y prime to dy dt now. Dt because, we're talking about a rate of growth, so we need it with respect to time. All right, and now we're going to go ahead and separate our variables. So divide both sides by y, and then divide both sides by y, and I multiplied by dt. I left the k on the one side because it's just some constant. I think it's going to be easier to deal with over there. Now we're ready to integrate. And when we integrate, we get ln of the absolute value of y equals kt plus c. And now we can go ahead and start solving for y. Slide this up a little bit. Exponentiating with a base of e, we get absolute value of y equals e to the kt plus c. And now we can deal with our constant at the end. You could totally, is it not writing now? All right, let's see if we fixed our writing issue. No, not, I'll go back here. All right, so absolute value of y equals, we know this plus c, hopefully we're familiar with that this plus c is just going to become a constant in the front. So you're okay if you go ahead and you don't have to write out that step. You can just switch it around and put the c in front of the e and have it multiplying like that. And then now, like we said before, I could say a is going to equal plus or minus c to drop the absolute value. And so we get y equals a e to the kt. All right, look at that. We solved for y. And now if we look at this equation, hey, that equation kind of looks familiar, right? Isn't this just our PERT equation, a equals p e to our continuous growth equation we had back in, trig pre-calc, algebra 2? There it is. We just derived it using our calculus, and now we know where it comes from. That's pretty cool. All right, the rest of these questions now basically just become ones like we've seen in trig pre-calc, where we're going to use our continuous growth formula and be able to work out some populations or exponential growth of various things, decay of things, right? So here our example we have now is the population of Clark County, Nevada was 2 million in 2013, right? Assuming an annual growth rate of 4.5% per year, what will the county population be in 2020? All right. Well, going back to our PERT equation, the equation we just came up with, and you can use either one. Again, they were the same thing. We had y equals a e to the kt, and we had a equals pe to the rt. If you remember that the r or the k, I guess, stands for our rate, right? The t is our time, p is the starting amount, or a is our starting amount, and the y or the a would be the ending amount of our population, right? So in this case here, a equals, our starting population is 2 million. I don't know. I guess we'll use the whole number. You could just use 2 and then your answer is going to be in millions. E, remember when you do the rate, you have to write it as a decimal, so 0.045. And then our time, we're starting in 2013, we're going to 2020, so that is 7 years. And now I'm just going to go ahead and work that out on the calculator. All right, so you can see down below here, when we plug this into the calculator, we end up with 2,740,519. And so that is our estimated population in 2020. Okay. Went and looked it up. The real population was actually more like 2.3 million, so we didn't grow quite as fast as I thought we should. but still not too bad. Interesting side note now that we've reached 2020 and beyond.